1960s, that people were beginning to understand the geochemistry of carbonate waters. And I thought, boy, we really could use more data. And at about the same time, Evan Schuster appeared looking for a topic for his master's thesis. And I had the idea of actually checking the springs on a regular interval of, a week or two or something like that. Evan was a caver, I was a caver, so we pretty well knew the valley. We just needed about a dozen or so springs. We knew where the caves were, so we knew when we were looking for springs, we knew where to look. It was one of the first times when this sort of new and revised and improved approach to carbonate geochemistry was used for a groundwater type of study. Just a big paper that kind of lays it all out, and so it makes a useful reference to use as a starting point for people who are writing up more recent work. This 2-week sampling interval that shows up in Schuster's data is an accident of the logistics. We found that he could, say, drive up Penns and Brush valleys, sample about 13 or 14 springs, come back, and then sometime the next day or two, analyze the samples, and then the following week he would go the other way, go to the southwest, down to Sinking Valley, and do the same thing. He'd go on up around the corner past Birmingham to where the 100 springs are, and then continue up the road. You would come to my uncle's farm, which is where I tried to teach myself geology a long, long time ago. We found out, of course, there are some springs in which the parameter, like, say, hardness and even temperature, varies all over the place, but with a pronounced seasonal cycles superimposed on a shorter term period related to storms. Whereas the other springs, like particularly the big spring in Belfont, they're essentially any parameter you care to measure is absolutely constant. And we thought, well, maybe that's because the variable ones are draining from caves, open conduits, and the others are draining out of deep fracture systems. We've learned anything we've learned that flow paths are fairly complicated things most of the time. Karst research has always been field activity. Actually, I'm hard put to think of an aspect of Karst science where the theory led the field observations. It's always been a case of piling up more field data than you knew how to interpret, and then having to sit down and think real hard about what it all meant. One of the things that's changed is our ability to put loggers into springs or into cave streams or whatever has changed the whole perspective of the timescale. And we learned with these studies back in the old Schuster days that the timescale for karst processes is a lot shorter than the timescale for most groundwater movement. Once we could put a continuous data logger in the stream, we realized that we've got stuff where the timescale is 15 minutes or half an hour. Fieldwork is changing perspective as the planet becomes more heavily populated, spread blacktop over a larger and larger area. What is going to be very important in the future are these cave preserves. Somebody's going on to somebody's property, looking at something, and coming back over and over and over again, making measurements of collecting chemical data on the water. So you have something like the Tuna or the Butler Cave Conservation Society, and you can set up long-term logging equipment or do whatever you want, and you don't have to worry about wearing out your welcome. What has happened over the last 20 or 30 years is that the cave and karst science is very nicely integrated into the rest of the geological sciences. You can judge this in the GSA meetings where there are tons of papers dealing with caves and karst. But in a sense, all science has now become multidisciplinary.